Here we have a motherboard that came in for repair. I do not know which laptop this motherboard belongs to, but we do not really care. The customer only mailed over the motherboard. He did not mail over the laptop. I do not know why customers do this. How can I test it? After I'm done with the repair, how can we test it? I cannot. We're going to charge the customer either way because we're going to spend the time to work on it. And if the customer does not want it tested, then that's fine with us. We're just going to work on the board and mail it back to the customer. Now, the first thing I want to do is locate the DC in connector. And we have a DC in label right here. So we're going to look at this area of the board, start from here, and see what happens. And we have a short. We have a short on the drain of the MOSFET. And that's a very good indication that we may have a vCore, a CPU vCore issue. I do not know what this is, but it doesn't matter because current sense resistors do not usually go bad. So if we measure in ohms mode, we should get 0 ohms. And we do have 0 ohms or 0 ohm. We're going to inject voltage on the drain and we're going to monitor the board under a thermal camera and see what gets hot. We may have a shorted capacitor somewhere, or if the CPU is the only thing that gets hot, it means that we may have an issue with the vCore MOSFETs. And now something is getting hot right over here. Inject again. We see a heat spot, release, heat spot's gone. Inject. All right, so what is getting hot? That's the CPU. We just had a customer that came in. I was talking to her and we changed the glass on her iPad 6. And she said, since we changed the glass on her iPad 6, the back metal housing got soft. It got weak, and now it's bent. I told her, what does the glass have to do anything with the metal housing? It's obvious that your kids may have stepped on the tablet because the tablet, she just brought it in like this. It's bent. So I told her it's obvious that there's an impact that caused it to bend. She said, no, the metal housing was strong before, but since you changed the glass, the back housing got weak. Let's continue with the repair. What can you do? How do you respond to this customer? I told the customer we're going to have to replace the housing, and she did not want to do it, so she left. She said, I spent money for nothing. If you buy a brand new vehicle and you hit the wall and the vehicle breaks, you just bought the vehicle, but now it's broken. It's an accident. Accidents happen. We did not make your back metal housing soft. How can we make metal soft? I wish I had that power. We have our GPU here, and our CPU is right over here. So let's go under. And, oh, I already see a problem. I already see a problem. Maybe I'm wrong, but I do see black burnt flux right here. Black burnt flux is an indication that the MOSFET got really hot. It released flux from under it. Flux should not be burned. Sometimes you do see burnt flux on the board, but it's not usual. If we look at the MOSFET right next to it, we do not see any burnt flux. The one next to it, we do not see any burnt flux. Next to it. And the only one that I suspect may be at fault is this one. A DC short is likely a shorted MOSFET. So we're going to start by removing this MOSFET and see if we can get rid of the short. And we'll take it from there. Right now, I do not have a reason to believe that we have anything else wrong with the board. If we had a shorted cap, it would have shown on the thermal camera. Right now, when we desolder the MOSFET here, then we can measure the DC MOSFET on the drain and see if we still have a short. If not, then most likely the problem is fixed. You see when you heat up the chip, how flux gets released from under? That's factory flux. I did not add any flux. I mean, look at this. I'm at 500 degrees and flux is not burning. So you can imagine how much heat this chip suffered in order for that flux to be black. But I may be wrong. Maybe the chip is good. I'm just assuming. Let's measure right here again and see if we still have a short. If not, then the problem is fixed. All we have to do is replace the MOSFET and send it back to the customer. Meter in diode mode, and do we still have a short? And we do. If we measure in resistance mode, 0. We do have a short. Okay, so I was wrong. We suspected that MOSFET is bad because of the burnt flux. But like I said, sometimes we do see burnt flux where the component is perfectly fine. But usually when we see burnt flux, it could be an indication that the MOSFET is bad. Before we resolder that MOSFET back on here, why don't we go through all of them? One of them has to be bad. We do not know which one. Is there an easy way to know which MOSFET is bad? I don't know. We may desolder this one, then this one, then this one, and the short may end up being here. Or we can start here, and the short may end up being here. If we do not start, we're not going to finish, so let's start taking out the MOSFETs one by one. We only have 5 MOSFETs, 1, 2, 3, 4, 5, 6 MOSFETs. If we are lucky, then maybe the short is coming from this one. That MOSFET is going to change color, but that's okay, because we are applying 500 degrees Celsius. Those MOSFETs are not easy to desolder, especially that the board is thick. So the board absorbs a lot of heat. And the board itself must reach melting temperature in order for that MOSFET to desolder. Melting temperature of the solder I'm talking about, not melting temperature of the layers. And let's check now, do we still have a short? Are we feeling lucky today? Or do we have to go over all 6 MOSFETs to find the short? Meter in diode mode. And the answer is, the short is gone. Wow. So we are feeling lucky. Not that lucky, but we are feeling lucky. We had to desolder the first MOSFET, and we were not lucky enough to get it on the first try, but the short is gone. We found it. We're going to solder the first MOSFET back on here, and we're going to replace the second one. And that's it. Our job is done. And that's MOSFET number 1. We're gonna reuse this one, unless this one is bad also. Maybe we had 2 bad MOSFETs. We took this one out, and then we still had a short, and thought that maybe this one was good. But we'll see. I'm gonna solder this one, then we're gonna check for a short. If we do not have a short, then that's the only one that's bad. I mean, what are the chances that we have 2 bad MOSFETs? Okay, those are all connecting as one. You see the big pad under, so it's okay if they bridge. Same goes for the top ones, it's okay if they bridge. Same goes for this. And same goes for this, one big pad. See, if you look here, 1, 2, 3 are 1, 1, 2, 3, 4 are 1, and then you have those pins, they are also 1, and then you have this 1, 2, 3, they are 1, and this one is separate. You got the point. And now that we soldered the MOSFET, the first MOSFET, let's see if we still have a short. If we do, then we have two bad MOSFETs, MOSFET 1 and MOSFET 2. What are the chances? And look at that, we have a short. So I was right about the burnt flux. MOSFET 1 and MOSFET 2 are bad. We're gonna have to desolder this MOSFET. This one is bad also. Both of them. What does that tell you? It tells you that I was right about the black burnt flux. That's what it tells you. Now I do have a replacement MOSFET here. We have enough solder on the pads. And let's test again. We have a short. And we do not have a short. Great. All we have to do is replace the second MOSFET, test again, and we're done. And we are done. All we have to do is clean up. Invoice and mail this back to the customer. We are all good. That's it. We're gonna invoice and mail this back to the customer. Time to go home. I hope you enjoyed this video. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.